Hi, in this video I'm going to go through part B of question 1 on the 2012 math paper. So in this question they've told us that n is equal to 2 to the k times 4 to the m times 8 to the n, and km and n are all positive whole numbers, and we want to know when n is definitely going to be a square number. So we can see that 4 and 8 are also powers of 2. So let's just write this whole thing as 2 to the power of something, because then it's probably going to be easier to try and work out when it's a square. We just need the exponent to be even. So because 4 is 2 squared and 8 is 2 cubed, then n is equal to this, and if we just collect all the powers, and so we get that n is equal to this, 2 to the power of k plus 2n plus 3n. So we see that 2 is the only prime factor of n, and if n was a square, then n is going to be equal to 2 to the something all squared, i.e. this power is actually 2a, so it's going to be even. So if we want this to be a square, we want k plus 2m plus 3n to be even. Well, okay, so we know 2m is always going to be even, right? So that means we need k plus 3n to be even too, because if k plus 3n were odd, then when we added an even number to it, we would get an odd number, but we want an even number. So we need k plus 3n to be even. Well, all we've got is things in terms of k plus n. So how can we turn this into something that will give us one of these conditions? Well, 3n is just 2n plus n, right? So we see that we want k plus n plus 2n, because that's just the same as 3n, to be even. And we know 2n is always going to be even. So that means we're going to need k plus n to be even too. So we want k plus n to be even, and we see that that is answer D.